Okay, so today we're actually going to be working with our calculators and logs. So this top portion, you don't have to worry about all of this vocab. What's important about it, I mean, it used to be more important back in the day when John Napier actually discovered logs and when he published his book and actually published more than like 90 pages worth of tables. So back in the day, you actually had to know what the characteristic was, which was the number in front, the actual whole number, and then the mantissa, which was the decimal part. In this case, you don't have to worry about it because now we have calculators, so we're not relying on all those tables. So now we're going to move on to the calculator portion. If it doesn't say how many decimal places to round your number to, just go with how many significant figures are in the original problem. So in this case, I have 1, 2, 3 significant figures, which means I'm going to actually want my answer to 3 significant digits. So I'm going to go ahead and go to my calculator. Now you'll notice that it's a log base 10, and this is our common log, and it's mostly called our common log because it's what our calculators came with, and it's the most commonly used log. So you'll find it right there. So I'm going to go ahead and press log. I'm going to go 4.68, which has 3 significant digits. So I'm going to try to round to 3 significant digits. So in this case, 1, 2, 3, and rounding it still is going to keep it as 0.670. The 0 is significant because that shows that there are more digits to follow, but I am rounding. And so in this case, if I round, the 2 is going to keep it as 0. So in this case, this would be approximately 0.670. Okay? The next one would be log of 3,400. Now remember, if you haven't gone through scientific notation, which is the previous set of notes, make sure you do go over it because it talks about the significant figures. So in this case, we're going to have 2 significant figures, so I'm going to round my answer to 2 significant digits. So I'm going to once again go to log, and then 3,400, and this rounds, if I want 2, that means I want the 3, and I want whatever this is going to be rounded. In this case, the 3 is not going to change it, so it's just going to be 3.5, and that would be rounded once again to 2 significant digits, or 2 significant figures. And if you do the same, I suggest that you guys do, you end up getting negative 1.50. Okay? Next, it says find y to 3 significant digits. So now it's telling us what we want. You have to remember that whenever we have a log, if I want to find y, I don't know what that is. So log form is not helping me. So I'm going to go ahead and turn this into its equivalent exponential form. In this case, the log has a base of 10. So this in exponential form would be 10 to the power of 0.4983, and that's going to give me what y is. So we go to our calculator, then we're going to go 10 raised to the power of 0.4983, and we get 3.1499. So in this case, I want to round to 3 significant digits. So that means 1, 2, 3. But I need to round. So this 9 is actually going to turn that 4 into a 5. So this is going to be approximately 3.15. Okay? You could do the same for the other one. Just make sure that you double check it and that you get y is approximately 3,030. Okay? Remember that this 0 is not significant, so it still has 3 significant digits. Okay, on example 3, now we have to find a value to 3 significant digits. So I'm going to go ahead and start with my base, 1.68, raised to the power of 8. And I want 3 significant digits, so I'm going to go 1, 2, 3. And so that 5 is going to round it up. So now it'll be, my good, 1.68 to the 8, yeah. So it'll be 63.5. So this is approximately 63.5. When you enter this, just don't forget that what you're trying to enter is 12.3 to the power of 3 over 4. So just make sure that your calculator does that. Just to double check it, we're going to have 12.3 raised to the power of 3 over 4. and then we press enter. And if I want to round to 3 decimal places, that is approximately 6.57. Okay, almost done. Okay, so on example 4, it's asking us to give the solution in calculator ready form, meaning what is the exact solution that we're going to be plugging into our calculator, and then we're going to give our solution in 3 significant digits. So first, if I want to get the exponent, I want to solve for x. I can't really raise both sides to the power of 1 over x, because that just seems silly. So in this case, if exponential form is not helping, I'm going to go ahead and turn it in log form. So this is log, and what I'm going to do is I'm going to actually choose a log of base 10. So what I'm actually going to do is I'm going to take log on both sides. So what I really have is log of 3.2 to the x equals log of 3. So all I've done is I've actually taken the log on both sides. From this, you could technically take log base 3.2, but I wouldn't do that if your calculator only has a log base 10. Okay, so I usually use log base 10. So I'm going to take the log on both sides. And it's the same thing as if you're adding to both sides or subtracting from both sides or multiplying to both sides. That is allowed. So in this case, I'm going to go ahead and lower my x. So this is equivalent to x times log of 3.2. And this is all multiplied. And this entire thing equals to log of 3. Now because I want x by itself, I'm going to have to get rid of this log of 3.2. So I'm going to divide both sides by log of 3.2. And then that's going to give me x equals log of 3 over log of 3.2, which should not be confused with the condensing formula. It is not the same. So from here, notice that I have 2 logs and they're both base 10. They're both a common log. So I could just go to my calculator and click log of 3, close your parentheses, and then you're going to divide that by log of 3.2. Close my parentheses, and my answer is 0.944. So this is a calculator ready form, and now this is approximately going to be to 3 decimal places, 3 significant figures, 0.945. Okay, and you should also ask yourself, does this even make sense? Does it make sense to get 3.2 raised to the power of 0.945, which is almost 1? So if you were to raise 3.2 to the 1, you would get 3.2. But having the exponent be shy of 1 means that you are shy of 3.2. So in this case, our answer actually makes sense. I'm going to go ahead and try the next one. But once again, you're going to end up getting, if you have x to the 3/5, I would actually not turn this into a log because the exponent is not, it's not an exponential function. You don't have x as the exponent. So this is slightly different. So you have this equal to 32. Because x is not the exponent, I can actually easily work with this by raising both sides to the 5/3. Doing that is going to give us x equals 32 to the 5/3. And I was thinking about taking the cube root, but cube root of 32 is not going to work. So this is our exact answer. And so then I'm just going to go ahead and plug in parentheses 32 raised to the power of 5/3. And I sometimes put parentheses just to make sure that it's not raising it to the wrong power. But I guess you could do it without parentheses. So this is going to give us 300, so this is approximately 322.5397888, and it's a bunch of them. But the 3 significant digits, that means I just want 3 of them. So he's going to round it, and this is going to be approximately 323. And it would make sense that if I put 323 and take the 5th root and then raise it to the 3rd power, it would be somewhere close to 32. Alright, one last example. We have something called the change of base formula. Calculators nowadays have any base you want. Even though it only looks like it has a log of base 10, it actually has log of any base. And I'll show you that in a bit. But back in the day, and by back in the day I mean like maybe 2 years ago, when we didn't have fancier calculators. You know, fancy calculators are like a thing of the present now. But maybe 2 years ago, there was no way to plug this into your calculator unless you spent a lot of money in your calculator. So anytime people had to actually figure out log base 4 of 7, they would be stumped. They couldn't plug it in. So we would actually have to do a change of base, in which case we changed the base of 4 to a base of 10. And we changed it to a base of 10 because that was the common log. Okay? So the change of base formula says that if I have a log base A of x, then I can rewrite it as log of any other base b. So this could be base 10, base e, base anything, of x over log base b of a. So you'll notice that here is my a and x, and here's my x and my a. Okay? So all I did is I rewrote it so that I have log of any base I want, which is preferable 10. So I could do log base 10 of the big number x over log base 10 of the little number. And like I said, b can be anything. It could be e, 10, 5, 4. But what would you make it 5 or 4 when your calculator usually has a log base 10? Okay? But it's always going to be log of whatever base you want of the big number divided by log of whatever base you want, has to be the same, of the little number. Okay? So in this case, if I have log base 4 of 7, this is the same thing. And once again, I want to just go from log base 4 to a log base 10, which is the common log. So this is log of 7, and it's a 10, divided by log of 4. And once again, it's always going to be log of whatever base you want, big over small. And this is not the same as the condensing formula, so keep those things separate. So now on my calculator, I'm going to go ahead and plug in log of 7 divided by log of 4. If you keep track of those parentheses, make sure that you close them, and your answer will be 1.4. And if I say 3 significant figures, then it would be 1.40. Okay? So this is 1.40, and once again, that's if I specify that I want 3 sig figs. Okay? So that's it. That's the change of base formula. For those of you who want to know, where is this base? You know, how do I actually enter log base 4 of 7? You can, if it's ever not on your keypad, I don't know if you could see that down here it says catalog, and it's pretty much going to keep track of all the things in your calculator. So I can actually go second catalog, and it's going to list them in alphabetical order. I want to get to the log, so I'm going to press the letter L in green. It's going to take me to the else, and then I can go to log base. If I click log base, it automatically has a base waiting for me, so that'll be a 4, and then this can be a 7. And if I do that, it gives me the same answer. But once again, you must know how to use a change of base formula, because you never know if you're going to get an older model for a calculator. What if your calculator dies on a test and you end up borrowing one? You want to make sure how to do it the old school way as well. Okay? So you are responsible for knowing how to do change of base. There will be a portion on your test where you will not have a calculator, and if you don't know how to do a change of base, then you're going to get wrong answers. Alright, so I think that's it. So good luck on your homework. Make sure that you also copied the 5.3 notes. And yeah, be productive.